Hello and welcome to 10.2 Surface Area of Cylinders. Today our learning target is going to be to find the surface area of a cylinder. Our success criteria will be measured by our ability to use a formula to find the surface area of a cylinder and find the lateral surface area of a cylinder. Remember that the lateral surface area, if you remember from yesterday, watching the example videos yesterday, the lateral surface area does not include the bases. So without any further ado, let's go ahead and jump right in. So today we're going to be dealing with cylinders. Cylinders have a circular base and then they have a rectangular lateral surface when you look at the net. So what I'm talking about is right here we have these two circular bases and then we have a rectangular lateral surface. So some good examples of cylinders are hydro flasks, coffee cans. I'm looking around my house right now. I don't know. Lateral, you can see cylinders in a number of different ways. Big grain silos are often cylinders. Okay. My well, I have a big storage tank for my well water, not the well itself, but where all my well water comes into. That's a cylinder. Okay. So when we're looking for the area of a cylinder, we would say that the surface area S of a cylinder is the sum of the area of the bases and the lateral surface area. When we're looking at this, we know that we have two bases. And we know that to find the area of the base for a circle is going to be pi r squared. Oops, sorry about that. Pi r squared. Okay? And so that's where that comes in right there. So our surface area is going to be equal to 2 pi r squared. And then area of the lateral surface is 2 pi r h. Okay? 2 pi r h. Okay? And that just comes from this lateral surface part right here. All right, so let's look at example 1. And it says to find the surface area of this cylinder, the first thing we're going to do is we're going to draw a net. And so they drew the net for us right here. You can see it's got this long, skinny lateral surface area followed by the two bases. So we're just going to use our formula here. So we're going to say surface area is equal to 2 pi. R in this case is 4 squared plus 2 pi times 4 times the height on this one, which is 3. And it's kind of hard to see that height is 3 on the net, but when we look over here on the actual shape, we can really see that height of 3. So 4 squared, which is 4 times 4 is 16. 16 times 2 is 32, so 32 pi, plus 4 times 3 is 12. 12 times 2 is 24. So 24 pi. So 34 pi plus 24 pi gives me 56 pi. And remember that we can approximate pi to be 3.14 or 22 over 7. So we would approximate pi here to be 3.14 because 56 is not, oh, it is. It is actually, hold on. 56 is actually a multiple of 7. So 22 over 7. So that goes into itself once. 8. And then you have 22 times 8, which is 176. Okay? Oh, square millimeters, because we are finding area, so it is squared. In this case, we were talking about millimeters. Okay? So I hope this part up here made sense. I just did 22 times 8, basically. Okay, so I'm going to encourage you to go ahead and pause the video and solve the triads, and then I'm going to erase all of my numerous drawings on here, and then when you come back, we will solve the triads. So let me go ahead and delete. Okay. All right, let's look at triad number 1. we've got a radius of 6 and we've got a height of 9. So if I drew the net for this, it would look something like this, where I would say my radius right here is 6 and my height right here is 9. This is yards, yards. So my surface area is going to be 2 times pi times the radius squared plus 2 times pi times the radius times the height. Okay? And then we are going to 6 squared is 36. 36 times 2 is 72. So we've got 72 pi. And guys, honestly, I'm sitting here with a calculator in front of me just doing some of this math. I know that 9 times 6 is 54. 54 times 2 is 108. 108 pi. So 108 plus 72 is 180 pi. Now 180 is not a multiple of 7, so we would use 3.14 as our approximation, and we would get 565.2 yards squared. That's what I got when I worked it out, and that is what my answer key says as well. So there's number 1. That's try it number 1, 565 yards squared. And then let's look at number 2. Number 2 would be quite similar. Our net would be just a little bit different. I'm going to delete that one too. Our net on this one would look just different in that we're going to have like a longer, skinnier rectangular part here. So I'm going to draw a long, skinny one. And the circles really should be in the middle, but you know, so we're gonna make it work. So this would be 3 centimeters, and our height here would be 18 centimeters. And I know that looks like it's the length, but imagine if you took this cylinder right here and you turned it up on its base, and then you could really see that that height was 18. Okay, so surface area is equal to 2 times pi times 3 squared plus 2 times pi times 3 times 18. 3 squared is 9. 9 times 2 is 18. So right here we've got 18 pi. 3 times 18 is 54. 54 times 2 is 108. So we've got 108 plus 18, and that equals 126 pi. 126 is a multiple of 7. And I know that because I just did 126 divided by 7. So I would come and I would do 126 is equal to 22 over 7. I had a brain fart, guys. 22 over 7. Okay. And then 7 goes into 126 18 times. So 18 times 22 is 396. So we would say that this one was equal to about 396 centimeters squared. And that's not equal to, that's times. So 396 centimeters squared. I looked in the book, and the book, I think they used 3.14 because they got 395.6. Okay? They didn't stick to their rule about, they said round to the nearest tenth if necessary. They didn't stick to their rule about using 22 over 7 if the number is a multiple of 7. So, hooey on them. All right. Guys, I really hate not being in class with you guys and not being able to ask you right here, are there any questions? Does anybody understand? Rate your understanding. Tell me how you're feeling. I really need to see your faces and need to see like how well we're doing with this. It's really hard for me not to do that. It's really hard for me not to go, okay, does everybody understand? Are there any questions? And it's like, yeah, Miss Crew, we have a lot of questions, but we can't ask any of them to you right now because it's 11:43 p.m. and you're recording this and we're not going to watch it until 8 a.m. the next morning. So, yeah. All right, finding the lateral surface area of a cylinder. All right, to find the lateral surface area, we're going to use the formula for the surface area. And what we're not going to include is the bases, okay? So remember, when we're finding the lateral surface area, if we're looking at it and we have like our net here, whoa, we have like our net here. There we go. These two circles right here are my bases. And when I'm finding the lateral surface area, I do not include bases. Okay, that's the difference between surface area and lateral surface area. So for this one, the only formula that I'm going to need is that the surface area is equal to 2 pi r times the height. Okay, and that's just going to give me the area that this piece right here holds. Okay, and what you would use this for, like, you would use this if you were going to wrap a hydro flask, because you didn't want to wrap the top or the bottom. And so you would need to see what the area of the wrap was going to be here, but you don't need to see. So you want to color just this part here that wraps, just like this part around here that wraps around your hydro flask. You don't want to cover the base or the top of it. So that's when we would use lateral surface area. Okay, so I'm going to try to erase all of this. All of this. This Chloe gets a little crazy sometimes with all of her drawings. And then, why are none of these deleting? At least I've sort of figured out how to use these programs and I'm not fumbling around as much anymore. All right, so we've got this circle. We need to know, so we've got surface area equals 2 pi radius height. So surface area equals 2 times pi. The radius here is 4 and the height is 5. They're like, wait, Miss Curly, the radius is 8. No. The diameter is 8. Oh, no. The diameter is 8, so the radius is 4. Remember that the radius is half of the diameter. Okay? Radius is half of the diameter. So 4 times 5 is 20, times 2 is 40. So we have that our surface area is equal to 40 pi. So we would do 40 times 3.14, and we would get that our surface area, our lateral surface area, is approximately equal to 125.6. We are dealing with feet, so this would be feet squared. Okay? That's that one. We're doing feet? Yeah. Okay. So go ahead and pause. I'm going to erase, and then we'll come back, and we'll work through the triads. All that fun stuff. All right. Let's look at triad number 3. We know our formula is going to be surface area. Lateral surface area is equal to 2 pi RH. So surface area is equal to 2 pi. The radius here, they gave us the radius, so it's 3, and they gave us the height, which is 4. So we've got 12 times 2 is 24, so 24 pi. 24 times 3.14, we would say it's approximately equal to 75.4 centimeters squared. Okay, and I did some rounding there because it was 75.36, and it told me to round it to the nearest tenth, which means I want to round it to this place, which means I look to this number to tell me whether this one goes up or stays the same. The 6 is bigger than 5, so I round it up. Okay? Now let's do number 4. Should we erase the formula? I'm just going to leave that circle there, guys, because it's just easier. So let's look at number 4, and I feel like using blue for number 4. Surface area is equal to 2 pi RH. Surface area is equal to 2 pi. Now here's where it gets tricky. They're showing me that the diameter is 3. So I know my radius is half of my diameter, so that means my radius this time is 1.5 or 1.5. Okay? So here's how I like to do these. When I'm dealing with like 1.5, I would break this 1 up into 1 and 0.5, and I would say 1 times 8 is 8. 0.5 or half of 8 is 4. 8 and 4 is 12. So 1.5 times 8 is 12. 12 times 2 is 24. So we have 24 pi. Huh, that seems really familiar. I'm pretty sure we just did 24 pi and we got 75.4 yards squared. Bam. It's actually 75.36, but like we just discussed, you gotta round it up. Okay? I know I did that one kind of fast, but it's really just basically plugging numbers into the formula. I know this is one of those guys where you're just gonna have to remember some formulas, okay? Okay, so let's go ahead and scroll on down to example 3. It says the iced tea can is made from a sheet of aluminum that weighs 0.1 or 1/100th ounce per square inch. You receive 40 cents per pound of aluminum that you recycle. How much do you earn for recycling 24 iced tea cans? So the first thing we got to understand is that we're given a unit rate in dollars per pound for recycled aluminum, the weight of 1 square inch of the can, and the dimensions of the can. Okay? You are asked to find how much we earn for recycling 24 cans. So that's how much do we earn? That's our goal there. That's what we want to find, how much we earn. So the first thing we're going to do is we're going to find the surface area of 1 can and then use that to find the weight of 24 cans. So let's start there. We want to find the surface area of this total can. So we're going to use the whole surface area formula, which is 2 pi r squared, because that includes my bases, plus 2 pi radius times height. Okay? So we're going to say surface area is equal to 2 times pi times 1.5 squared plus 2 times 5 times 1.5 times 7. Okay? So let's get started. So this is going to be 2 pi 2.25. Why did I write 5? 2.25, which is actually equal to 4.5 when you multiply these two together. When you multiply the 2 and the 2.25, you end up with 4.5 pi. And then we have 1.5 times 7, which is 10.5 times 2, which is actually going to give me 21. So 21 plus 4.5 is 25.5 pi. Okay. And then we're going to multiply that by 3.14. So 25.5 times 3.14 is equal to 80.07. But we're just going to keep it at approximately 80. Okay? So the surface area of 1 can is 80. It's 80 square inches. Okay? So what we're going to do now is we're going to multiply that. I'm going to kind of erase some of this. Erase all of this. We're going to multiply that 80 times 24 because there's 24 cans, and we know that each can weighs 1/1000th of an inch, 1/1000th of an ounce, 1/100th of an ounce. Oh my goodness. Right here they tell us that each can weighs 1/100th of an ounce per square inch. So we have 24 cans. That's where the 24 cans comes in. We have 80, each can is worth approximately 80 square inches, and they weigh 100th of an ounce per square inch. So we're going to do 80 times 24 times 100th, and we get 19.2 ounces. So that means that in our 24 cans, we have approximately 19.2 ounces. Okay? Now, here's where it can get tricky. If all of that wasn't tricky enough, now we have to find out how much we make for recycling the 24 cans. We know that we get paid 40 cents per pound. We're not dealing with pounds right here. We have it in ounces. So the first thing we have to do is we have to convert from ounces to pounds, and then we have to convert that to the amount of money that we earn. So we're going to do 19.2 ounces. which is OZ, times 1 pound over 16 ounces. Because 16 ounces is worth 1 pound, times the 40 cents per pound that we get, okay? So we can see we've got some things here going on. We've got a lot, okay? So because I have ounces over here and I have ounces here, they cancel. And then I have pounds here and I have pounds here, they cancel, okay? So now, basically what I'm going to do is I'm going to do this 19.2 times 0.40, because remember, this is over 1, so it's 19.2 times 1 times 40 divided by 1 times 16 times 1. So basically that looks like 19.2 times 0.4 divided by 16, okay? 19.2 times 0.4 is 7.68 divided by 16 is a whole whopping 48 cents. So if I recycled 24 aluminum cans, I would earn 48 cents. Okay? So you gotta save a whole lot of cans to make any money recycling those aluminum cans, okay? So I hope that makes sense to everybody. I really, like I said earlier, I hate not being able to see you guys and ask. So your homework will be posted in Big Ideas. Please let me know if you have any questions. You know how to get a hold of me. There's various ways that you can get a hold of me. I will be holding office hours tomorrow from 10 to 2. So let me know if you have any questions, and you guys have a good day, have a good evening, and I hope to see you all real soon.